Good morning friends. In the last lecture, we have seen some of the specific incident ray and according to it, we get some of the reflecting ray also for the spherical ray. Which are they? I just repeat it. First of all, when the ray is parallel to the principal axis, you get a reflecting ray which is passing from principal focus. Which is denoted by capital F, right? The second one, when passing from principal focus, it will remain parallel. To principal axis. It will remain parallel to principal axis. The third one, passing from center of curvature. It returns back on a same path. It returns back on a same path. And the last one, unpole, reflects back at same angle. So here it is the four specific incident ray and here it is the reflected ray. We are using two of them for forming an image with the help of spherical mirror. Which are they? The first one, parallel to the principal axis. You have to always remember them. When the ray parallel to the principal axis, after reflection, it just passes from the principal focus. You have to use this ray for each and every image formation by a mirror and lens also. So you have to remember it. And the second one is the passing from center of curvature because it is a lazy ray, right? We does not need to draw another ray for it, and just because of that we are using here a passing from center of curvature for most of the image formation. In some of the image formation, when we can't use this one, at that we have to use this one. But mainly we are using this and the here. So, when you want to form an image with the help of spherical mirror, during that time you have to use the first ray and the third one parallel to the principal axis and the third one passing from center of curvature C. Passing from C. These two rays should be used for forming an image. For that, I am taking the first image formation in which the first one is at here. Image formation. It is the most IMP topic, okay? Image formation by concave mirror. It is a 3 marks question. There is a 6 image formation. From there, one of them can be asked to you in a exam for a 3 marks. So here it is, image formation by concave mirror, in which you have to use a concave mirror and you have to put an object at some distance. For forming a concave mirror, I have said you that how can you draw a concave mirror? For that you have to take a rounder of a 6 cm radius. You can take any of these, right? But 6 centimeter, why we are taking here the 6 centimeter? Because it is convenient to your book, page of your book, right? And just because of that I am saying that. But if there is some measurements are given to you, then you have to use that measurement for draw that mirror. Okay, at here we are using only 6 centimeter. So take the rounder of 6 centimeter, put the one point in the middle of it, and then draw a mirror like that. Then you get a mirror. Which type of mirror is that? Wait a minute. Okay, see. Which type of mirror is it? Is it a concave or a convex? You say that it is a concave mirror. No, actually it is not a concave mirror. Why? Because I haven't plating of a silver in any side. If I plate it at here, then it will become a convex. And if it is at here, then it will become a concave. So I am just plating it. There is a hair, right? You can imagine like that. So here it is a plating. So you can say that the reflecting surface is inner sidely curved. So it is a concave mirror. Now we have to draw a principal axis. You have to draw this principal axis which is passing from the center of circle. At where you have put it a point, then draw it, right? So at here there is some point. You have to draw a line passing from that point, okay? And that center point should be indicated with this C, which is a center of curvature. The line which is passing from the portion of a mirror should be indicated like a pole, P. So it is P and here it is C. The distance between C and P is 6 centimeter because we have taken a radius of 6 centimeter. Here it is the center of a circle, right? And here it is the one point of a circle. And just because of that, the distance between both of them is 6 centimeter, which is the radius of curvature. Now you have to take the center, a midpoint of it. Means if it is a 6 centimeter, then you have to take at a 3 centimeter, which should be indicated as a F. It is a principal focus, right? So C, F and P. The distance between P and F is 3 centimeter, while the distance between F and C is also a 5 centimeter. It should be in a center. So here it is a center. Understand? So there is some points, some of the terms related to concave mirror, a pole, a principal focus and the center of curvature. Now we have to form an image. But which object's image you have to form? Then for that you have to put a object at here, right? Then where should you put the object? You can put any points at here, right? In front of a reflecting surface. You can put at here, here, at any, right? Okay. Where should we put at here? Then I am just telling you that. Okay. Here it is the position of object. Where we are putting an object at infinity distance. At infinite, right? Object is at infinite. Okay. Then where should we put an object? See, where should we put? At here? Then is it at infinite? At here? At here? At here? Here? No. Infinite means you can't see. It is just so far away from this mirror. So you can't put an object because it is at an infinite. If any object is at infinite, then the ray which is coming from that object is always parallel. And if the object is exactly perpendicular to the principal axis, which we are always putting at here, then all the rays which are coming from that object are always parallel to the principal axis. So you have to put two rays which are parallel to the principal axis. Which are parallel to the principal axis. So here is the two rays. The first ray and the second ray. As you know that for forming an image we need only two rays. So I have drawn two rays which are coming from the object which is at infinite. We can see just we have to draw two rays which are parallel to the principal axis. So here it is the incident ray which are parallel to the principal axis. If this ray is parallel to the principal axis, then after reflection, which direction it will go or by which point it will go, that you can say that at here. Parallel to the principal axis, then it reflects from the principal focus. So you have to pass it from the principal focus. So here it is a reflected ray. You have to draw an arrow. Then you can say that it is a incident or reflected. Here it is reflects from the principal focus. Now the second ray, it is also parallel to the principal axis. So it will also passes from the principal focus after reflection. So you have to draw a ray which is passing from principal focus. Okay. And where the image is formed. In before some videos I just say you that if you want to form an image of this point at here, then some of the rays we have to take only two of them because we are so lazy, we does not need to draw a more rays, we don't want it, and just because of that we are just drawing a two rays. When these two rays meet at some point after reflection, that point will be the image of object. I have said it, right? Then this point will be the image of that object. At here, we are also doing that. At here, the rays are coming and they meet at some point. At where? On principal focus. Then it is the image of that object which is at infinity. So accordingly, we can say that, what we can say that the position of image what is the position of an image on principal focus. On principal focus. Understand? Now, the nature of image. What is the nature of that image? There is two types of nature. I have said you that one is the real one and the second one is the virtual image. Right? Is it a real or a virtual? The rays after reflection they actually meet at a one point. So you can say that it's a real image. Right? Here it is a real image. Understand? Because it's actually meet after reflection they are actually meet at a point. There is no any virtual effect like that we have to extend it in a backward side or something like that. It's actually meet and just because of that we can say that it's a real image. Not only that, I have said it that if the image is real then it is always inverted and the virtual will be always erect. So if it is real, then it is inverted. So the real and inverted. Real and inverted. Now the size of an image. What is the size? It is very small, just a point. Right? The image is just a point. They are just okay. As you know that when we draw an image like that during the time we are just passing a two rays from the head. After reflection they meet at one point, then you get the head point at here. And you have to extend it towards the ground, then you get the foot point. And you say that here it is the image. But at here, the head is at here and foot are always on this point. फुट तो ऑलवेज ग्राउंड पे ही होगा ना, तो अगर यहाँ बी है तो बी भी यहाँ पे ही होगा इसी ग्राउंड पे. सो ए डैश एंड बी डैश आर at a same point, or you can say that this image is just a point. So it's a very small, highly diminished. This image is highly diminished or a point like. It's just a point. So it's a highly diminished image. Understand? So here it is the first image formation by a concave mirror in which the position of an object is at infinity. When object is at infinity, you get the image on the principal focus. This image is real and inverted, and it is highly diminished. It is very small or a point-like image. Understand? So here it is the first image formation. Now this second one. Okay, in a second one we are just draw it here. Okay. Now if we take a position of an image on principal focus, what occurs at here? When at infinity we get on principal focus. But if we put an object on principal focus, then at here you have to put an object on principal focus. That you know that object is on principal focus, here it is a principal focus, so you can easily put an object on it. Then at infinity, so you can't see that object, or just you have to incident a parallel rays. But at here you can see a principal focus, so you can put an object at here. So here it is an object. I am putting an object at here. If I am giving it a name as AB, here it is A and here it is B. The name of object. Now we have to use a two rays for forming an image. Which one is the first? First is parallel to the principal axis. As I said, so here it is parallel to the principal axis. After reflection, it passes from principal focus. So it is passes from principal focus. Now the second one, passing from center of curvature. Okay. As you know that the center of curvature is in the other side, not in the side of reflection, right? It is in the opposite side. So you have to put a scale like that the C and A can be easily connected with each other. Then draw a line like that. Then just extend it in a forward one and in a backward. Then what you can see at here, the two rays are just going parallel to each other. There is no change in a distance between these two rays. Understand? If the two rays are parallel to each other, then you can say that they will meet at infinity distance. At infinity. They will meet at infinite. If one object is at infinite and a ray coming from that object is parallel, then these parallel rays can be also meet at some point, or you can say that they are negligibly comes nearer to each other, which can't be recognized by our naked eyes, and just because of that they can be seen as a parallel, right? And just because of that we can say that they are just partially or very negligibly they comes nearer to each other, and after the infinity distance they will meet at a single point, or really they will meet. So you get the image at infinity distance. They are actually made at a infinity or anywhere, but they are actual image, and just because of that you can say that this image is real. And if it is real, then it is inverted also. So here it is, position of an image is at infinity, while the nature of that image is real and inverted. Okay. Right here you can see that if it is moving and moving and moving, right, then you get the image at infinity distance. If we think like that at here, okay, if these two rays just meet at here, then you get the image like that. If it meets at here, then you get the image like that. Meet at here. So if they goes away from the mirror, then the image will becomes bigger and bigger. Understand? So if it meets at an infinity distance, then you can say that how much bigger that image. It is so big, right? According to this object. Object is very small. In front of it, the image is very big. If here, then you get like that. If here, it becomes small. At here, it becomes small. Like that. Understand? And it is just meeting at an infinity distance. So your image will becomes a very big, or you can say that highly magnified. It is highly magnified. This image can become a highly magnified. So if the object is at infinity, you get an image on principal focus. If object is on principal focus, you get an image at an infinity distance. Both images are real and inverted. But for an infinity one, you get the diminished image, and for the principal focused object, it will be a highly magnified image. Understand? So here it is a two image formation by a concave mirror. You have to write it in your notebook and draw both of the figures like that. I have just written on a board. In the same way you have to write in your book, but you does not need to vanish or something like that. You have to draw both the figure in a different page or in a one page, but one by one. Not you have to rub it and then draw it and something like that, which have I done on the board. Okay, understand? So you have to draw it in your book. Understand? Another 4 will be studied in the next video. Thank you.